Hit the lights!
You've discovered the Halfwatt podcast. We want to educate and entertain by tapping into the most trusted source of new technology, the ones installing and innovating it. You, the tradespeople that build from the ground up. Join us as we talk with industry leaders, veteran contractors, and even some young blood.
Welcome aboard. Today I have a returning guest. It's Mr. Gary Youngberg.
Hi, Mike.
Welcome aboard. So Gary is a nice set 4. He's the best systems integrator, I'd say, west of the Mississippi for EST, since Morris lives east of the Mississippi.
Mr. Wizard.
I'm sorry, I snorted. Hey, but what we want to talk about tonight is technical stuff. Really get technical and to teach some folks some stuff and tell some sea stories.
Okay.
And so you've got one about a guard. And when you worked at ADT.
Yeah.
And did you hurt the guard or what happened?
No. So let me cue this up. It'll take a little bit. I'll try and move it along. So,
go ahead.
As you know, I've been doing this a long time.
I've heard.
But at this particular time, I was a newbie. I only had like 15 years in the business. Mm-hmm. And so we had guards at ADT. And we all packed.
Oh, they had 15 years.
So, yeah, well, I did. I only had 15 years. I was a newbie. So, pardon me, we'd get these guards, and they would go out on service calls or trouble closings, or the fire transmitter wound down, and they had mechanical with the skate key, and you had to wind them back up. And so they said,
wait a minute, hold on. Now, for the children's out
please.
there,
Thank you.
Go back, because you had ADT had guards.
Yeah.
Guards had watch. Did they wear the big Flava Flav clock, that kind of thing, or what?
No.
What were they doing?
So they wore firearms.
Really?
Yeah,
ADT had firearms.
Yeah, I used to carry.
You used to carry for?
When I went on service calls, you're darn right.
No kidding.
I was on a service call one night fixing the system while people were trying to break in. I wasn't carrying on that call.
No kidding.
And we didn't have cell phones, so it's not a matter of dial. You had to find a landline. You had to hope it dialed 9 to get out. And so anyway, I got my permit.
I had no idea, Gary.
I got my permit. Yeah, my dad made a lot of money catching bad guys.
Huh.
So anyway, the guards primarily would go out on trouble closings, or if there's an alarm and they had guard service, they'd beat the cops there. And they
which makes sense.
Yeah, and they all packed, and as a repairman I could pack, and I did. But so the guards need to know how to do basic troubleshooting. And since I was the lead repairman there at ADT and here in Portland, part of my job was to teach the new kids. So we'd get the new ones, and I'd take them out for a couple days and, okay, not that one, or this one's going to be good. And that was a path to getting to be a repairman back then.
Okay.
So anyway, this kid's about 6'3", maybe, $140 dripping wet. And he has his vest. He had his bulletproof vest, and he had his stuff, and went out to the service call. So what had happened is McCullough circuits. We talked about that back in the day. It was hardwired through the central station. The power came from the central station, and they ran on 52 volts. And then the first boost was 78, and the second boost was 130 DC, 50 milliamps.
Wow.
And when you touched it, it woke you up.
That would hurt you.
Yeah.
Wow.
So we get a signal in the middle of the night on this customer over by Lloyd Center. Actually, it was in Lloyd Center. And partway through, the signal just died. Clickety, clickety, clickety. And it just died, and that grounded out. So it grounded the circuit. Of course, our operators called Telco, and Telco did their thing. And, it's coming from this address, blah, blah, blah. So they didn't want to pay for overnight service. So the first thing in the morning, we get out there. So they said, well, take Bob with you. All right, fine. So we pull in, and he gets his 3 toolboxes out. He's got his vest, his coat, his firearm, these toolboxes. And I go, kid, what are you doing?
Yeah.
And he's like, we need tools. I said, no. I looked at, and listeners can't see it, but I had a little notebook just like this. It was a little 222 book. It was an ADT part number. It's just a notebook. You talk it for logging your service call. I said, I've got this. I've got a tweaker screwdriver. Got my pen, flashlight. That's all we need. So we're guaranteed 3 trips to the truck on every service call. What do you mean? You leave your truck, you talk to the customer, you see what's going on, assess the situation.
Okay.
Go back to your truck, get the tools.
Okay.
make the repair, put your tools away, go back, have the customer
Talk
sign
to
the
the client.
paperwork, tell them what's going on, yada, yada.
Documentation.
Correct.
Thank
and
you.
And you know I hate paperwork, but I did it.
But we all know as senior technicians that the job is not done
until the
paperwork is done.
And,
Kids, remember that.
Yeah, it's just like if you go to the restroom. I mean,
Yeah,
I'm sorry,
exactly.
you got to have the paperwork.
What are the clamshells for? That's a different story.
There you go. Okay. So anyway, we get queued up, and so the first part of the troubleshooting, the central station told me the transmitter died halfway through the signal. They got 2 rounds. They were called rounds. So let's just say the code was 312. I think I picked out on the last one.
Because it was wound up. It was a motor that was wound up.
No, this was the electronic ones. It was really cool.
But it would send three rounds.
However many rounds.
Okay.
3, dit, 312. Do that 3 or 4 times. Well, they'd got a couple rounds. It died.
Okay.
And they're like, what the heck's going on? And so they weren't sure. And you can have clashes because it was a series circuit, and we've talked about that basic. So it died. So I get the work order, and right there out of the gate, I already know it's wrong. But I'm supposed to train this kid.
Sure.
So I keep my mouth shut. All right, kid. We have clues. So anyway, he's still carrying his boxes. So we walk into the subscriber. They're called subscribers. And first thing I walk in, the roll gate's open, and you trip over a floor polisher stuck in the middle of the floor. Great big old cable hanging out of it. Okay. Observation is your best tool for troubleshooting.
Nice. Thank you.
So
Thank you
here
very
we
much.
go. So, the first thing was Central Station told me part of what the problem was. Now I walk into the premises, and there's a floor polisher stuck in the middle of the floor.
Another clue.
And I knew what was wrong, but this is just cementing what I know. So I asked the kid, what do you see? Oh, okay. He doesn't pick up. I said, you got a floor polisher sitting there. That's a clue. Over his head. Because he's too gung-ho. He's too in the moment. He's not got the zen or the chi or observing. And when I'm not ticked off, I just hum. And so I wasn't. I was teaching this kid, and so we walk in, and customer comes up.
I have the same problem.
Yeah.
If I'm too ticked off, I can't get zen at all.
So, I'm trying to set the example, and like I said, I was Youngberg. So pretty soon the customer comes up, and he's sitting there, and he, oh yeah, well, we were polishing the floor last night, and that quit. We were waiting for the electrician to come in.
Bingo.
Oh, okay, right. So,
there's another clue.
And it's a big fat cable. So I look at the cable, and it goes over this plug. And guess what's right below that plug?
Yep.
The
transformer for ADTs.
Right.
Magical.
Right, the transformer.
Transmission.
So I says to Bob, see anything, Bob? No, I don't know. So I said, well, that happened. Yeah, the electrician's coming, but so glad hand to the customer, did the schmoozing, and so we're gonna find out what's wrong. We'll get you back in business. Okay. So I look at Bob. You see anything? No. Where's the panel? Panel's over. So we go over this hallway, and as I see that, about 10 feet down is the main breaker panel. Now, I'm looking down the hallway at the control panel. It's a big old blue box. It has a meter that goes white to green because I don't like talking about my burglar alarm days, but I did do burglar alarm, even though fire's my thing.
No, I get it.
And I look to the end of the hall, and I says, Bob, the answer's in front of your face.
Yeah, find it, kid.
And he's all over the board. He's just everywhere. And, well, the meter's not green. I said, of course, Bob. The roll door we just walked in is open. And he's just so excited to, I guess.
So a green meter meant that everything was secure.
Everything was secure. Okay. But like a fire panel has the green LED, what we call a green panel, where everything's normal and the power.
And you got one light.
Well, guess what? The old days, the lights were red. Guess what wasn't lighting on the panel? So here we've got a hung-up transmitter, a polisher dead, plugged into the same plug that our transformer's in.
There you go.
Looking at the end of the box, the light's off. I go,
you're spoon feeding this kid.
And so I said, Bob, I know what the problem is, but I'm not going to tell you.
Good.
This is part of, well, what? And he's just getting all excited, and he's frustrated, and he's just jittering. I mean, he was just, this tall, skinny kid, go. said, okay, I'll let you walk up to the panel. He gets his drill out and he starts to, and they had those 6 mile long bolts that ADT had on their dang panels, Put that down. What do you, put it down. Mm-hmm. The problem's in front of your face. And he's looking all over. And I'll admit, once in a great while, that LED would be burned out. It was a thing with that particular ADT panel, but it was like 1 out of 1,000. It wasn't, and he still didn't get it. And I'm just shaking my head. He's looking for the key. Well, does it have to be turned on and off to reset? No, it's easier than that. Mm-hmm. And I couldn't get him to check the obvious.
Mm-hmm. You can't get him to slow down long enough to finally really absorb.
I took my tweaker, pointed the red light, and well, what's that all about? It's out, Bob. I said, so let's go over to the breaker panel, which was 10 feet from the plug. I said, before I open the breaker panel, take a look down there. Mm-hmm. Look at the polisher that's dead that we almost tripped over. Mm-hmm. We throw the breaker panel open. The little lock that keeps it from accidentally being turned off at night, of course, it's up against that, and it's tripped. I go, look, the breaker's tripped. I said, now watch. And I pulled my tweaker out, and I undid the breaker lock. Snap, snap. All of a sudden, I hear the brrrr, and it sends the final rounds in because now it has AC power.
Yeah, now it's ready to rock and roll.
And I take my tweaker and I put the lock back on, shut the door. I said, fixed, just like that. Mm-hmm. And the kid was just dumbfounded.
Yeah.
And then I said, but we're not done. Those are gel cell batteries, which in those days were brand new to me. Mm-hmm. We had wet cells. Yeah. And so, as you know about gel cells, sometimes they go in deep discharge, they never come back.
Sometimes they can't.
Sometimes they go down in reverse. Sometimes.
Oh, wow, I didn't know.
Yeah, they would actually reverse polarity sometimes.
Huh.
And other times they got all the green goo that's going down the side of the back.
Yeah, that's I've seen that a lot.
So,
and most of the listeners probably don't they realize now that they think those are SLAs, but they're not. Mm-hmm. These are all AGM batteries, but the SLAs had a small weep hole in them.
Yeah.
And remember the brand that the top would pop off? Mm-hmm. And then all
Yuasa
the goo
or
would
whatever.
All the goo would fall out. And you're like, well, that goo is sulfuric acid. Enjoy.
And then I got another troubleshooting story for batteries, but
nice.
We'll let you get yours. So I let Bob do this. I get my tweaker and I turn it sideways. Then somebody really tightened these screws down properly. So okay, get your tools out. So he undoes it and we look, and sure enough, one of the batteries had dropped in deep discharge. I said, now.
So how did you tell?
How?
Just because it wouldn't take a charge, it would pull too much
I'm
current?
sorry. Yeah, thank you. I left that part out. So get the door open. You got the green goo.
Okay.
Clean it up.
Oh, I see.
Put the meter on it. Okay. Yeah, this one's at 3.7 volts on a 6 volt. It's not coming back. Yeah. The other one's at starting to come back. And
they weren't really good at marine batteries at that point. Mm-mm. Like they didn't make a good deep cycle battery for a while, especially when they first started in that industry.
So then he says, now what? Well, now we go talk to the customer. Hey, Mr. Customer, yeah, I don't have that size battery in my truck. You can't carry every size battery for every panel that's out there. You'd end up with 2 semis. Yeah. So I said, now we have to trip back to the shop. So now this is 4 trips to the truck, right? And because he just, the quickest service call I ever did was 2 trips. Went in, nice. Talked to the customer, yada, yada, yada. Yeah, it was our fault. We reset. Okay, have a nice day. Go get the paperwork, sign it, back. 3 trips was the general go, because that's the customer service end. You go in, you glad hand the customer, you assess. Yeah. So anyway, we go back, get the batteries, get them in. Had digital meters by then, thank God. And you could see it was taking a charge. It was go up a hundredth of a volt at a time. Okay, that one's taken, yeah. Clean everything out.
Hold that thought.
Yeah.
So for those who are not familiar with, we'll do with AGM batteries. When an AGM battery or any lead acid battery is completely depleted and you attach it to a charger, it'll draw an arc. And the resistance on the battery is extraordinarily low. There's all the electrons are getting back on the plates and they're putting electrons on one side and a need for electrons on the other. And then the resistance of the battery begins to rise. So if you do a voltage reading, if you do a voltage reading of a battery, when it's discharged, and you put a charger on it, you can watch that voltage go up as the resistance increases because the voltage drop is going up.
Right.
Okay? So kids, when you put your meter on a battery, if you put it on just one battery and it's at 10.7 volts and it should be at 12 and it's been sitting on the charger for X amount of time, it's a bad battery.
Correct.
And if it's not increasing
a little bit,
then you've got something wrong. And if you take it off, and it should start to drop. And it's that, but a lot of people don't realize that with lead acid, when the battery's depleted, there's no resistance.
Yeah.
And now they know when you hook up to a dead battery, you get the arc, but that's why you get the arc. So okay, go ahead, please.
Thank you, Mike. Yeah, and so the advent of digital meters was great because trying to see that on an old Simpson.
Simpson 260.
Unless you turned it to 12 volts, which if it went over, it'd peg it. But if it was under and you could see 10, and you could watch it move up by just a very a hundredth of a volt on an analog meter is hard to pick.
It is.
So
but
anyway,
you can see it on a digital really easy.
So it's doing that, and I'm showing him, okay, so now it's taking a charge. We've cleaned up the terminals. We lied to it. We threw a strap on the input so it cleared, sent the signals, resent, made sure the transmitter was all good, checked the coding, checked the relays. Yeah, all good. And, because they blew the breaker, that was a chargeable service call. So then we filled out the 524.
So did Bob ever become a technician, or did he shoot himself in the foot, or what?
No, he became a good one.
He's not going to show up here at the studio.
No,
and
he won't.
Butt,
I think he moved off and went and did something completely outside. But no, Bob.
I'm going to go outside. I'm Bob.
I think he found a woman and moved off. But he became.
That happens
he became a good troubleshooter, and when we got him to slow down, and you know how it is when there's some people you just know if you can get them to slow down, they're going to get this, and he got it, and he was like, oh my gosh. And I said, yeah, I've chased bad meter leads around a warehouse before. When you've been around as long as I have, you have these lessons. You too, you've been around a while.
Oh, yeah.
Check your meter. Yeah. And you hold the leads together. And I use alligator clips. I won't use your thumb stuff because if you're measuring fine resistance,
if you're measuring but I still teach the students just grab a resistor and hit it with your thumbs because.
But, if you don't check those leads before you start off troubleshooting, you can be chasing a set of bad leads all around a warehouse.
And I have. I mean, and you would not think like Fluke, which makes a beautiful meter, like the leads would ever fail. You're like, these things never fail. I have. Our producer says this happened to him.
Yeah, okay, there we go.
You're like, these things don't fail, and sure enough, they do. And they look perfect. But the more you use it, the more you're twisting and
twist and pull and
crap breaks, man.
Yeah, they break even though it's flexible cable.
Well, let me go ahead because I want to tell you about mine. Mine today.
The big takeaway I think here, and it's one thing when I teach people I start off with. There's only 3 things you need to check in troubleshooting. First thing you check's the obvious. Okay. Second thing you check's the obvious, and when you're still not sure, check the obvious.
I like that.
Majority of the time. Majority. Now, I'm not talking about the one-offs where the manufacturer has some bug in the program. Right. I'm talking about just everyday troubleshooting. Yeah. And an old guy taught me that, and now I'm the old guy. But it works. I mean, that was a perfect example, and I couldn't have teed that up any better. It was just handed to me, and it's like, here's this perfect training experience with this brand new kid. Yeah. And he's so eager, wants to learn, but he can't see the forest through the trees.
Yeah, because you got to kind of prime the pump.
Yeah.
And then they get hold. And then when I trained a guy who became a fabulous technician. I mean, I started off just kind of hinting at what we're doing, and then he way surpassed me. We had one started yesterday, and we had 2 simultaneous problems going on in this building. And old building, old wiring, old everything, right? And for people who haven't had the pleasure of working on a system that is SLC and has
conventional.
I call them hybrid.
Okay.
And I teach this because I've had a lot of folks come up and go, well, this is a 5820. So it's just an SLC system, an analog addressable system. I'm like, well, the head end is. Yeah. But if you got modules out there, first you're going to have modules on all of the water flow devices. So you're going to have to know at least that part of it.
Correct.
Which learning water flow is its own gig. But in this case, this was supporting a zone of 12 conventional heads. And as they were testing it, the head would go into alarm. The base would show, but it wouldn't show up on the system, which is a daunting thing. And so my apprentice was working on it, and he called me up. He goes, I'm kind of baffled on this. Come give me a hand. And I said, well, what kind of what kind of a base you're using. We had the base that was on it. So he went and found another like base and put it on there, same problem. Okay, well, now we've switched the base, so it's not the base. So he goes, I don't think the head's compatible. And in Simplex, they had heads that had dog ears and some that don't.
Okay.
And if you didn't have the dog ears, if you had dog ears, they wouldn't fit into the bases that didn't accept them. But if you did have a dog-eared base, you could put either kind of head in there, although one's incompatible. So he goes and finds all these, and these are old heads. These are heads that are older than him. So we get the head in there, and it won't work. And so I said, leave it the way it is. And, tomorrow when I get a moment, I'll come over this. So I look at it, and I said, I do everything he does just to confirm the problem. I reach up with a set of alligator clips, and I trip the base without the head in it. And sure enough, base goes into alarm, but doesn't do anything. And everything's fine. He's done everything I've taught him. Mark which side's got the EOL, mark the side where the zone is. And I said, this is a wrong base. Now, why it came up now is because somebody who's testing paid attention. They've been tripping this for years. And the light's been coming on for years.
And they called it good, but didn't check the panel?
And they called it good, but they didn't check the panel.
Darn.
So if you have 12 devices on a zone, and each one, the little red light comes on, then the system worked, right? Well, that's a bad squeeze. They didn't do anything.
No.
And this kid caught this. This is how smart he is. So then he goes through. I said, well, I said, I'll tell you what I want you to do. Go get me one of those thin bases, and I pointed out the base I wanted. Go get me one of those. So he runs off and goes and finds it. He knows where this stuff's hidden all over the campus. And immediately I wire it back in, and right off the bat the thing trips and does exactly what it did. So now I go to show him. I said, so the reason this other base didn't work is it was a relay base. So it was expecting, the base is designed to take the zone power and power up a relay. And it tells you on the back its current pole. And I said, I'm going to take a wild guess that this has never worked. And at some point, we'll have to go through all the heads on here and see if they actually work, just to be sure.
Because we're talking about a two-wire circuit that puts a soft short on the circuit.
Yeah, exactly. Exactly. So the idea here, kids, is that you have a base with 4 wires coming in, right? 2 coming from the feed and 2 going to the inline resistor, and then a head that goes on there. The head shorted. It did its job. It saw smoke. It shorted. It did what it's supposed to do. There was not enough current in the base to give enough shorted current for the module to see it, because all the current was trying to drive the relay. And the relays, these are old relays. These are like pull start relays. So they don't have enough current to do it. So something's got to give. So there's enough current to turn the LED on, but not enough current to short across that zone.
And that is
and
why
put the module in alarm.
Relay base smoke detectors on 2-wire circuits are no longer allowed for elevator recall.
Because they don't work. And if this is
see,
that just opens up a whole can of worms. I was doing a building.
My job.
When I worked at PSI, we were doing a building that the panel exploded on us. Just exploded. It was an old Edwards panel.
Yeah.
And it really easy to get the power supply, go sideways on the power supply. Remember those ones where the bottom flipped out, and you had those panels you had to pull off, and the daughter cards were all inside. Okay, it was one of those at 57, I don't know.
5703.
That's 5703. One of those.
DZMs, dual zone cards. Yes.
And
I got a story about
somebody
IBM
who
with
shall
one of those.
remain nameless
Yeah.
was working on the power supply, got the wrong power mixed up something, and kaboom, power's gone. So we got to drop a 5208 in there, or I think it was a 5208 in there to cover it. And sure enough, I get to the elevators, and they're 2-wire
smokes
with relays.
Oh, dear goodness.
And so they were tripping, especially when we put the new system on. The Silent Night's got enough power to drive, whatever it needed to. The problem was the relay itself arced over.
Uh-oh.
Now, its elevator recall is a normally closed circuit. Everybody in the fire alarm industry is used to normally open and it closes on alarm, except for door circuits, which are always closed and they open on alarm. Elevators are almost always closed. It's always a closed loop. It fails safe.
Shunt trips are too.
Exactly. If you cut the wait a minute. Shunt trips are.
Yeah, shunt trips for either elevators.
I thought they're open and they shut.
No, you hold that current.
You hold it closed all the time.
You hold the current. And I got the troubleshooting
Oh,
story.
I did not.
I
did
might
not
have told on
realize
the last one where I almost got electrocuted at this
Yeah.
big place, having 480 in my hand instead of 120.
My bugaboo on the shunt trips is still the fact that we're not using those conventional heads for it, but that's a
Yeah.
separate story.
Right.
So we couldn't get the elevator to work right, and I eventually, as I pull the relay apart,
Mm-hmm.
the elevator trips. So I reset it and go back and look at it. Can't get it to go because of the amount of current that the elevator was pulling through that little tiny relay arcs them over. Because the contacts in the relay are moving a half a millimeter, maybe 3/4 of a millimeter.
So it just jumps.
So it just jumps it, and now it arcs it shut. Now it can never open.
Yeah.
And the elevator will never recall. So it was one of a couple of issues we had to deal with on that panel. But how do we expect folks who are, who grew up with iPhones and iPads and PS5s and didn't have to slave in the conventional Simplex 2001 world, world,
ADT 1101s.
To know this
wind
crap.
up transmitters.
So there's all this knowledge that all this, and I call myself an old timer, even though I'm not nearly as old as you.
Not quite. You're getting there.
Every damn day. How are they going to pick up what we're laying down? I mean, if you send somebody out I'm going to pick on Simplex. You send them out to a 2001 repack. They don't know what the hell that is. Mm-hmm. What the hell's going on with this? And there's all those, and then there's those types of panels, and then there's this panel has all these issues, and it's an industry thing where that Edwards panel has this problem,
right? Or that ADT
that Simplex panel
or
has this
Simplex
problem.
or whoever.
That happens sometimes with these, right?
I talked to one of our guys about his troubleshooting the EST panel, and he has some audio problems. I said, well,
your favorite.
And it had to do with, and you got to be old guy on EST, but if it's a copper network.
Okay.
And
so copper network
between all the nodes.
All the nodes are not using fiber to communicate. They're using copper
pair,
RS-485.
Right, and it's Class A. And
it's
then
Class
the
A.
ASU is a Class B. And for some reason, in some revs of firmware, if the ASU audio circuit doesn't follow the same path in the same direction as the network, and they're going backwards, you get
kidding.
Random amplifier faults.
Oh, no kidding.
Now, I have every tech fax that EST made since I started working on that in 99.
I did not know that.
And it's just like they had a problem at this big place where the planes land.
Oh, I've heard about that.
And I worked for another place. Well, now I'm digressing to programming problems, but they...
Where the planes land.
So anyway, they made these things for lazy programmers. And I listened to Mike give me a jab on the last podcast about because I'm too particular in programming. But it's like, thanks, Mike. That works.
True.
Baker.
Yeah.
Well, they have this personality. You can call it door holder. Okay. Mm-hmm. And it makes programming easier for people that aren't into it.
Right, because you can use that term.
You can use that
fills
term
in all the blanks.
And I write it. I am right down to you've watched. I'm just.
So you don't use the preset.
Well,
and I know what it is in Simplex land, but I don't know what it is in EST land. So you don't use the preset.
I don't use the
things.
preset personalities like door holder, fan control, whatever. It's all pre-named. And what happens, the compiler makes a mistake, and it sometimes doesn't grab them all.
Okay.
I have the original tech fax from EST that said, never, ever, ever use those things. And then, of course, I'm like, why don't you get rid of them?
Yeah, why do you leave them in?
Use NSO, non-supervised output.
Okay.
And then use your command lines in your language to pick that. Well, some lazy programmer, and it wasn't Mike, so just make sure it was somebody else, used that. Because it was going to streamline the programming. And they were testing this left and right, and it wouldn't work. And Charles was the boss back then over there. And, they're asking everybody, and, I kind of just quietly said, well, I know it's wrong. So we get this big conference call with the client, all this, because, we're missing the dates and yada, yada. I said, let me look at the program. I look it up. Yeah, they went back to using door holder.
Mm-hmm.
Well, for whatever reason, the compiler doesn't always grab it, especially the way the rule's written. So rewrote the rule to grab it by the qualifiers we put in the label.
Output.
You know, star.dh1 door hold series 1 or door hold series 2, whatever the qualifier is. You know, on dh1. And then you run your rules report, and here's this big list of things that are supposed to happen.
Nice.
Do the download to 40 some odd plus panels and test it, and oh my God, guess what started working?
No kidding.
Because somebody got lazy, didn't listen to what the manufacturer told you, and what I talk about, check the obvious.
Right. And it in the programming world, you know, because that's the thing as a technician, and of course we're all fire alarm monkeys here. But
right,
I apologize to folks who are not fire. I know, but
I did security. We just don't talk about that because that's what's on sale today.
That's mean.
What's on? Well,
there's
going to
be a whole host of security people out there.
I know they're
going to
send messages. So I have done.
Where's
security.
this guy do this at?
Yeah,
I'm coming after him. I like DSC, but no,
I
mean too, well, that's a whole different. It's a whole different world. I mean, you know, I've seen security guys sit down with a panel. You know, they jack in with an enunciator, do the code, and with two thumbs, they're as fast as somebody playing on a PS5. I mean, they're just wrecking through that stuff because they know every
old
every
ADT
character.
panels were like that. Some of the old ones, I was pretty good with the old panel
totally
programming that way, but when they came out with keyboards and human interface, I'll take a keyboard.
That's what I'll take almost any day. But
even DOS. DOS was easy compared to that stupid.
I still use it, so I know.
Remember having to hit the 9 key 3 times to get a Z or an X or a Y or something?
No, I didn't have that. But some of the
had.
simplex panels we still use. When you do the programmer, it's a DOS programmer. So it comes up in a DOS window. And you're actually, it's simpler because there's no mouse controls. It's all keyboard.
And your F keys will move around faster. You can jump with F keys, right?
You know the freaking, you know the stuff. But it's a nice primer because when you look at the new programmer for like the ES, you know, it's like all Windows based. But when you really get down to the core, the programming is almost exactly the same. You just have like 9 million more options on what you want to do. You can really go sideways on an ES. But you know the difference between the generations of panels. Like I look at the old ones and I'm like, well, you're good. I mean, you do really well. You really do good. You look at the new ones, you're like, I mean, because you can download to them. You're downloading 5 times the amount of information in 1/10 the time. It has backups. It's so smart. It does health checks. It's like this thing is the new stuff that is out is good. Anyway.
Well, I talked about when I was the ADT Central Station Tech, I think the last time with the Intel 330 box computer with the 8.5-inch floppies.
Yeah, and that's the original.
And so for anybody, when I mention ADT, I'm talking about the old ADT, not this new one that's been passed around like a sports ball. I'm talking prior to, well, I had something else, but you can't say it on the radio. Prior to all the buyouts. And I left ADT after Holly Holdings bought them out because it just changed. It's not the same ADT anymore.
Just changed.
So.
Well, yeah, because you look at some of the old ADT stuff that's hanging on the pipes. It's been there for 50 years.
Oh, I know, and it's still working. Yeah, stuff was
you
built
could beat a brother
bulletproof.
to death with some of that equipment, dude. It was like you opened it up, you're like, this thing's bulletproof.
Well, I think I covered this on the last visit, talking about drilling PIVs and tapping a 1 3/16 hole for their doggone post indicator valves. The 611 with the little black.
I'm surprised you remember all that.
Remember when I first came to work at PSI, they sent me over to Milwaukee to this client, and I'm going, I remember when this was United Grocers. Yes. Oh my God.
Yeah, and matter of fact, I went to troubleshoot that PIV, that one that we're talking about, and figured out why it wasn't working, right? So I had this client, they put new pipe in underneath the ground. And then, you know, because of the type of system it was, and that was an old ADT system, and it really worked well. I mean, was it an ADT? No, they changed it to
radionics.
Radionics.
ADT,
but it had a
radionics,
like a radionics head end that was a computer-based head end. I'd never seen anything like it, and it was kind of cool. Like I could have really sort of played with it, but all I need to know is the EOL is 49K, and here it is, and that's it. Boom, 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 in and out.
Well, when I worked on it, was still on McCullough's system.
Oh my God! It's just amazing how you watch all the generations of equipment go through a building. Well, and then when I go through, my wife hates it because I go through. I've worked there.
Oh, my wife, when she was alive, the same thing. She says, "Oh, you're such a geek."
Yeah.
What are you looking up for?
She's like, "Do you want me to tell you every building I've been in this town?" I'm like, "No." But I've been there. I've been there.
So that was, exactly. And so I had a student stay after I subbed for Dave last night. And we were talking, and I think he works for a division of your company. And
Sure.
He's talking about how he wants to program, do this, that, and the other. And I've got a young lady who works in our company I'm trying to mentor, and she's going to be an awesome programmer. But what the kids are going to miss, unfortunately, because he says the kid last night says, I like the parts and smarts, and so does the young lady that works at PSI with me. But they're missing the part that built up to,
all that old school technology.
I taught people how to cut in door strikes back in the day when we had card readers at ADT. I was a central station tech. I mean, you could wallpaper my house with all the certs and the training they sent me to, which has played forward when I got my NICET certs and things like that. So though I don't have a degree, it was all strictly OJT. But they're going to miss that part that I had by actually doing that work. And I can walk into a place sometimes and just look, and I know where the problem is. And I don't know how I know, but I just do.
It's experience, Gary. Because so we got one today, same building, right down the hall, Signal circuit. It's a NAC circuit. They called them Signal at the time. So signal circuit, 10K EOL, and when the thing turns on, it shorts. Okay, so as soon as you see a signal circuit that is normal, so it's seeing its EOL when it's
sounds like a diode blew out,
or something's wired backwards.
Yeah.
So we thought, okay, well, this will be easy. Something's wired backwards. We'll kind of walk around. Nothing's making any noise, so that's not the problem. So I go to start taking this thing apart, and because now you're dealing with generations, plural, of technicians, plural, in this building, which was built in the early 1900s, which turns out was last century. You're dealing with all this stuff, right? So because I'd worked there before, I know, the hidden magical place here is in this office and through this door and around here, and then there's an old 2120 multiplex cabinet, BMUX cabinet. You open that up, and then there's like someone vomited wire in here, and that is where I'm going to start. And and for whatever reason, I just went, I'm just going to start where if I was here in 1994 or 5 or whatever it was, it would have been 98, 99. This is where I would have started, was right here. I wouldn't have gone anywhere else but here. And that's exactly where I started the problem. So I quickly intercepted it, pulled it apart, found my EOL. But when I measure my voltage, I've got, I think, 5 volts. So something's loading the system down and eating basically 23 volts. It's 28 volts when it's normal. It's eating 23 volts of. So I got a voltage drop. I got a big resistance out there, and it's wacky. So I start to half split and pull the circuit apart. So I pull the circuit apart, find the EOL, realize that it's not there, and then start looking at the wiring and go, well, this is going up this raceway, and then I got a pair of black and reds going up here, black and reds coming back, and I got a pair of baby blues over here, and I can see where people have tied all these different things together, start to pull it apart. So then I make an educated guess, and I go down the hall and half split at this NAC in the hall. Take it apart. There's my black and red, so I can see, and it's got tape on it. I'm starting to pull it apart, and I just finally go, well, I got to go above the ceiling, and I can do that in this building. So I pop the tile and I open it. Oh my God! Here's 4 squares, right? So 1 4 square with an extension on it and a red cover. I open that thing up, and it is solidly packed. solidly packed.
So what they did is they put the extension ring on after they packed it, and the only way to work on it
They
is take
packed it with a hammer, and they just crushed it in there, and there's just crap coming in and going out, and I just was like, uh-oh. So I began to pull this thing apart, right? So
You're brave.
No, not take it apart, but just pull the wire nuts, pull them out in groups and start to break it down. Break it down. Okay, well, it goes in, goes out, goes in, goes out, goes out. So I keep looking at this, making notes, bringing my apprentice up, looking at it, and he's just going, my God, I don't know what the hell's going on here. This is scary. And I'm like, yeah, it is scary, but we'll figure this out. So I make educated guess. This line runs to some mystery spot down here because it's got to come back. And so I've got my power feed here, which is coming from another floor, by the way. So it goes from 2 to 1. And then it goes from 1 out from this BMUX panel all the way out into the field and just goes here and there and everywhere. It comes back and then goes to the baby blue wires, which cover the wing I'm in, and then there's an EOL at the end. And my apprentice goes, well, when we tested it, the last one didn't fire, which makes sense. I says, yeah, my guess is there's not a voltage to run it. I mean, we should probably turn on and measure it, but you can't because it's the middle of the day.
Right,
and,
that's
you've got
where you're
children
at.
and stuff like that. So I start to take this thing apart, and I mean, it spent an hour, Gary, laying this thing out, going, okay, it goes in, it goes in, and the back of my mind's going, something's wrong. Something is obvious, and it's right here. So I jump down the ladder, I draw it out for the kid, and he goes, yeah, I see that. And I have him go up there, look at it, and I said, something is wrong, right? You see it too. And it was one wire was off. So when they in the ins and outs, they had crossed one.
Oh no!
So I fixed it. Like, okay, got it. Move, because it takes you a while for your brain to connect. Logically switch it around, throw my meter on it. I gain 2 volts, maybe 3. So I've still got a problem in the field. Yeah. And I'm like,
so it's multiple problems.
So it's
on
multiple
this
problems, right? Bingo. Yeah. So now I've got, so I explained what I need, what we're going to do. I left, and I laid everything out. And I said, yep, for sure. Now I'm going, power coming in, going to this device, coming back up, going down this loop, coming back, going down to this loop, coming back, going down to this loop, which this mystery. We don't know where the hell these things are going.
Right.
Coming back. We're changing colors of wire 4 times. So you've got red and black here, red and black here. Then you've got FPLP, FPLP. So you've got red and black, red and black, red and black, red and black. And then coming back, we got a 4-conductor, red, black, blue, brown.
Oh, not even yellow, green.
No,
blue, brown.
No, blue, brown. Who the hell uses that, right? Shielded, no doubt. And then it goes off to back to the panel. And so I look up, and it's been a solid 6.5 hours. I mean, a solid 6.5 hours. I didn't even stop to eat. I think I used the restroom once. That's it. I'm so in the zone. I'm so zenned out at this point that I'm just like, I must continue. And thank God I'm in a job where I don't have to answer my phone. I'm not the guy I don't have to go to the meetings. I don't have to. All I can do is just sit here in pure troubleshooting
mode,
bliss, and work on this thing. So I get it all put together the way it was, and I put it back together again. I go back to my desk, and at this point I'm famished, so I eat like
voracious.
I think I ate my apprentice. He was tasty, so whatever it is, I ate him. I ate everything there was to eat, and when I got back to my desk, and I sat down, and I cranked out a document, map, and then I started drawing it on there.
Oh, nice.
Right. So then I drew what I knew. Yeah, exactly. And normally I do that electronically, but I'm using like Bluebeam Review or something. Now I just crank out the thing and draw it on. Looked at it, and because this is the second time I've drawn this circuit out, maybe the third time, and I explained to my apprentice that, hey, this is a technique that I do. If I'm baffled, I'll come and teach it to you or show it to you, and I'll either pick it up or you'll go, what the hell's wrong with you?
Right.
Same thing like your young man at ADT, where he was missing it, even though it was right in front of him.
But you don't know what you don't know.
You don't know what you don't know, and you don't know that you've got yourself vapor locked on this issue. It's this, but it's actually some other issue over here, and you refuse to take your mind off of that. And that's the trick, is to back up and go, no, let me explain this. As I drew it out for the second time,
Remind me to tell you about the Clear Alaska trip.
let's do it. So I figured out, oh, well, okay, this has to be the problem. Now I gave instructions because he's going to have to ring these bells tomorrow morning to see what the hell's going on when there's no people there. And I says, I'm going to bet that you're still going to have a short when it runs, but go ahead and look at these 5 issues I wrote down and let me know what you see. Give me your observations on that. And we did the same thing on a door circuit we're troubleshooting in a children's hospital, where when you've thrown and this is a job where I can throw 8 or 10 or 16 hours into it, and the company is paying me to do that. Where if I'm a service tech, and I'm showing up, and I don't know what building I'm at, I don't know what that's a whole different kind of troubleshooting. So you gotta go. You got that.
Can be detrimental to good troubleshooting.
Bingo. Where the best troubleshooters that ever worked for me or I've ever worked with don't give 2 craps about how long it's going to take. They walk in and I'm talking troubleshooters that I know from PSI, where they walk in and they go, yeah, I'm going to turn my phone off, or I'm just not going to answer it, because they're solely focused on that job and they're not thinking about that they have to be somewhere at noon. They're focused on where they're at right now and what the problem is and moving down in that.
And the only time I answer my phone on those is when it's the person at the other end of that circuit I'm troubleshooting.
There you go.
We didn't have that back then.
No.
Remember you had phones with the long cords? You carried the long cord to extend the handset?
We still have a phone with a long cord. It's just invisible. Yeah. But that whole thing, the having the time, finding your zone, and I don't even realize that I've spent 5 or or 6 hours on something until I pop out of it and I go, why am I so hungry?
Yeah.
What the hell's wrong with me? I gotta get my emergency snack bar because something's going wrong. And then I finally go, okay, now it's a good time to stop, recollect my thoughts. We'll find the problem. Within a couple hours on Monday, we'll find the problem. Yeah. We'll have nailed it by that point. And the amount of labor that we put in, and this is a problem that has been there
for ages.
We solved another one, and I'll shut up after that. We solved another one in just as old a building. And I had an apprentice that was, he subsequently found he just didn't want to do this kind of a gig, but I drug him with me for 5.5 hours, and we solved a problem that ground fault was there when I was there in the 90s.
Yeah.
And we solved it in 5.5 hours. And I mean, we doggedly went after this. Yeah. And when I finally found the problem, it was the type of cable that we were pulling. I never thought about it as when I first got there, but we had this armored 4-conductor crap that we pulled everywhere. And the shield on it was it's jacketed, so it was FPLP, so it's jacketed with a braid over that, with another jacket with a shield over that. So there's a million ways you can ground this thing, and when you go to cut it, you could not pull the wires apart to strip it back because it's like a tank. It's braided. So you have to physically cut the braid.
Cable or something?
I don't know what the hell it was.
CI cable with
it wasn't even that. It was garbage cable.
Okay.
It was made by Garbage Cable Company.
Okay, there you go.
In Wisconsin. No, I don't know what the hell it is. But we must have had a mile of this crap, and we pulled it every freaking where. And almost every single ground fault I've troubleshot since I've been back
been on that cable.
Has been on that kind of cable, or it has been a shielded cable used in the wrong application. Why would anybody use like 14.2 shielded to pull a door circuit? Kids, if you were pulling a shielded cable,
because it was on the truck,
or
the supervisor or the PM or whomever said, use this up, it's already paid for, we got to make money on the job.
If there's a hell.
Did I say that out loud?
You did. Okay. If there's a hell, the guy who pulled shielded cable for door circuits is in it.
Yes, hopefully.
He can be right next to me. So I can throat punch him every 20 minutes. Oh my God. Don't ever pull shielded cable in an application when you don't need it.
Yeah, ever. Stop it.
Okay, I'm over.
Okay.
Rant's done. Man.
All right, so
I have my... pissed off right now. I can barely stand it.
My next 2 troubleshooting things are play it through to the end.
Okay.
And sometimes you need to walk away for 30 seconds. I'm serious. So I come into work I was at Intel. I can say I was working there because it's a trailer, but it wasn't Intel. I get a call. They want me in Alaska tomorrow.
Okay.
L&D's, this big Clear Air Force Base. Now, talk to the wife.
Well, hey, when the Air Force needs you, you gotta go.
So I talked to the wife, and she's like, yeah, go. Sure. And I'm like, it's cold. Yeah, I'm on the way. I don't do heat. I had a heat stroke at 4. I don't do heat. I'm a cold weather person. Love cold weather. I hate heat. So I volunteer. Nobody else wants to go. So can't get the flight. I go the next day. So it's called Clear Alaska because it's clear in the middle of nowhere.
Oh, all right.
And I got real lucky because I got to stay in the house that the electrical we were sub to was there. So it was an old IRC3 system with Signature, which is an SLC, a type of SLC.
The original SLC.
The original. Now,
the original, like, pull start SLC that Edwards made.
But it's the same one that's used on the 3. It's just the interface was really, really clunky.
I remember seeing a couple of those panels.
The ZAS2 interface. It's
this is
horrible.
A scary system.
So we were 4 days from L&D's. Nothing's working. The particular branch up there in Alaska lost a bunch of good people.
L&D means?
Liquidated damages. Thank you. Yeah, when I jargon up, make me stop. So, it was exciting. There was no holds barred, get it done.
Sure.
Lots of overtime, not with the wife. Okay, it's great. I had 4 small kids at home, newly remarried. Anyway, so I'm up to the Air Force Base. I'm doing this. And they put me in the house and give me this room. And I said, well, where's the drapes? Well, nobody but bears and moose can see. I said, no, it's daytime. I landed at 2:30 in the morning. Yeah. You could see.
Yeah. Sun doesn't go down. So.
It was, you mainlanders. So that was to preface the next part. Pardon me. So I'm trying to start this up, and I can't get these stupid devices to talk. I'm going over. Pretty soon I'm starving. And it seems like it's only been 15 minutes. It was 7 hours.
Wow.
The sun doesn't move in Alaska, and I didn't realize how I key into the sun.
Oh, I didn't think about that. Yeah.
So I said, to heck with it. I went back to house, made hamburger, whatever, came back. 10 minutes, had it solved.
Oh, no kidding.
I'd looked at this pull station a dozen times, and I'd try and download it, wouldn't take it, wouldn't map it, wouldn't do anything.
Is it backwards?
Innies and outies were reversed. On EST modules, you feed in on 4 and 3, and you go out on 1 and 2. And I looked at it a dozen times, but I was so into, I'm going to make this work, then I'll go eat. I'll make this work, go eat. Sometimes when you're troubleshooting, you need to step back just a second.
Yep.
In the old days, everybody smoked and drank coffee.
Yeah, you go out for a cigarette. Honestly, and the techs that smoked, even in the Navy, the techs that smoked are almost always better than the techs that didn't, because you had to take a break.
And your mind resets.
Your mind resets.
Yeah. Okay, so you know how with all the new panels and stuff, and I'm the old guy. I actually started a year before Baker. I started in 77. Even though he's older than me. He went into service. I didn't at the time. So the next place is High Rise across from the convention center downtown. And it was an old MXL panel. And then they replaced it with an XLS. And I led a team on that one. And that was what I did. My whole career up until I came to work for Landis before it was Siemens, was retrofit stuff. And Dad always told me, anybody can hang a brand new device on a nail and wire it up and make it work. But if you can go into the garbage pit, the junk nobody wants to touch, and fix it, you'll always have a job, kid. Dad was right.
Yeah.
So the old panels were 10 times, by a factor of 10, less sensitive to the EOLs and the grounds.
Oh, I did not know that.
EST is the same way, by the way.
Oh, no kidding.
So when you go from an IRC3 to an EST3, you will find ground faults.
It starts picking up all these ground faults,
good. Yeah. So I had this plan.
I did not know that.
So when I ran retrofits, we went out and we checked all the circuits with our meters, and we got a circuit list, and you'd find grounds.
Keep going. I want to see if I have a picture of this.
So we'd done that. We identified some. Okay, fine. So then we go to light up this XLS, and it's grumpy. It's got these grounds. Can't see inline resistor.
It's grumpy.
It's grumpy. I got other words, but we're on the radio. So we got everything tested. We got it cut over. It's during COVID first started, so it's kind of made it easy. The building wasn't occupied. These 2 circuits out in parking would not work. The resistance was off, too. What the heck? Voltage is wrong, just like you talked about. How many resistors do you think I had in parallel on that one circuit?
A bunch.
4.
There you go.
I found 4.
There you
so
go.
I stepped it through with the kid. Still wouldn't work.
Mm-hmm.
So, and I put the meter on. I put on diode check.
Mm-hmm.
Couldn't find diode. And I'm moving my hands back and forth with meter leads.
Sure.
This was weird. And I've been doing it a long time. This was only about, so it'd be like 42 years.
Mm-hmm.
And I've never seen this problem in my entire career. Well, the MXL panel's a workhorse. It's like the IRC3. That old MXL panel's, it's got some stones, and it doesn't care. It's going to blast it out. The new XLS panel, if it gets in too much resistance, I can't do anything. It stops. And they all do that. They're supposed to fold back.
The new stuff is kind of babyish.
So
it's wimpy.
I had the head of engineering there at the building helping me, and we're troubleshooting. And so we get 3 horn strobes going off, or speaker strobes, and nothing else passed. And they had sealed them all up because it was weatherproof. No, leave a weep hole, silly. Don't seal it up. This is Oregon. Leave the doggone weep hole. So, of course, they filled with water. Okay, well, that one's grungy, so he had a new one to replace it.
We should go double back on that.
Yeah.
So that people understand what we mean.
Oh, on the weep
Because
hole?
there are times if the conduit is in the ground or in cement, it's going to have water in it.
Absolutely.
And
it's like a terrarium.
It's like
literally.
a terrarium. And you can seal the whole AV if you seal the EMT coming into it. So if you've got EMT coming in from the ground and you hermetically seal that.
Coming from the ground, though.
But if it's, yeah, that's true.
I got to correct you, Mike.
I've
I've seen it.
It should
I've
be.
seen EMT.
It should be lots of things, Gary.
Yes. Okay.
Well, but if it's plastic, right?
It's the same
not going to
properties.
ground, but it's going to have.
It'll still fill with water.
They still fill with water, and then if they pulled FPLR, right? It's not a waterproof cable, so it's just a matter of time.
And it will seep through that
before
jacket.
it seeps through that and gives you other new and remarkably crazy faults, right? I mean, that was a huge deal.
Yeah.
And we, but if you do have conduit and you've hermetically sealed the conduit.
But that never happens.
But it doesn't happen, and most people don't.
Yeah.
But if you take RTV, silicon 2, and RTV right where the wire's coming out, and put in an inch of RTV, there's no more moisture coming through that.
Right.
So that will stop the moisture from going in the AV. Then you can seal the AV till the cows come home.
Right.
But if you don't, then as the weather changes and the water hits that vapor point, it vaporizes and comes up in, and it condenses and vaporizes and condenses and vaporizes and condenses and begins to corrode knee crap. Yeah,
exactly. So that's what happened. We replaced this one. Still not working. What the heck? So that's 1. Count 1. Something's still wrong. Ended up on this circuit of NACs in this parking garage were 5 that had the strobe diodes blown out. I still have one in my shop. I was going to bring it in for training.
No kidding.
So I had never seen a diode blow out on a NAC circuit before, on a NAC device.
How the hell do you do that?
Lots and lots of power in reverse.
So the diode, folks, keeps
the steering diode.
It keeps it when a NAC circuit on a fire alarm system is when it's not operating, when it's at quiescence.
Correct.
It's reversed polarized. So for those of you who don't work on fire, if you see plus and minus on a signal or a NAC circuit and you put your meter on it, it'll read reversed.
Depending on how it's labeled.
Depending on how it's labeled. Yes.
Trust me.
Yes, that's true. I forgot that. But generally, like let's suppose red's positive and black's negative, and the silk screening on the motherboard says this is where your positive lead goes and this is where your negative lead goes. You put your meter on it, it reads opposite.
When it's normal.
And then it will shift polarity and then operate. And what that's doing is when it's reverse polarized, the blocking diodes are forcing the current all the way to the end of line resistor, which is whatever resistance it needs to be for that panel to be happy, and then comes back to the panel. When it shifts polarity, then each of those NAC appliances will operate.
And let it pass through the appliance.
And let it go through the appliance and make it beep. So Gary's saying is that those diodes
were blown,
which would then, and so they'd stay open or they'd blow short.
I think they must have been open because
and they just wouldn't work.
The strobe wouldn't work.
Yeah.
And when I put my diode checker on the bad one, It was like wide open.
Yeah. So rarely would I look at the internal components on one of those.
And we don't because we just chuck them. But I found 5 of them. And it's like, how did these pass inspection? Because the last inspection was at this client's place. And I'd never seen that many blown things on the same circuit in my life. So I asked the client, they let me keep one because I said, I got to. Because we get the brand new one out and you put your diode checker on. Oh, yeah, that's happy.
It works perfectly.
And then we put the new one in and that one works. But everything downstream doesn't work. And we ended up changing 5 of these things on the same circuit in this parking structure. And I've been doing this a long time, and I had not seen that.
So, you know those Ultronic NACs? Have you ever seen those the Ultronic NACs?
Oh, the new ones?
No, the older ones, the ones that have been around a while. When you open them up, you're like, there's a lot going on here. Like, there's a lot going on there. Like, the motherboard is, like, layered.
Oh, yeah, I remember those.
Okay, so there's a building downtown that has those things in a parking garage. So they're in the garage, embedded on the wall in the garage.
Yeah, they don't like that though.
And they don't like that, right? Yeah. And so we go to work on it will intermittently go into trouble. Just out of the blue, I'm in trouble. There's no reason.
Not happy.
And so I sent a crew down there. They tore the wiring apart. I mean, they just freaking tore it apart. All the NACs are wired correctly. All the wiring's good. There's no shorts. There's no grounds. There's no runs. Everything is perfect. Thing goes into trouble. We do the obvious thing. If the field wiring is good, the appliances are good, and everything works okay,
go back to the panel.
Go back to the panel. So we went and
dummy it up.
I said, get me a motherboard. So we ordered another motherboard, put a new motherboard in there, and it didn't. And the same exact thing happened. So it would go into trouble, and then it would clear. It would go in, and it was completely random. It didn't matter if it was 6 a.m, 6 p.m. And when it did, it bothered 2 clients because the building is shared with 2 different clients. Driving both bats not crazy. Yeah. It was like an apartment complex in a grocery store. So I'm like, oh my God, what the hell am I going to do with this? I eventually put a timer in there where it's not UL listed, but it's for that. But it was one of those ones where
Ultronics makes
it was either an Ultronics
listed.
or an Alpha Omega. Yeah. But you could set up where if this thing trips for X amount of time,
it'll push it through
and it'll track whatever it is.
I've done that before.
Yeah. So then the trouble has to stay on. The logic was you have to have a trouble that stays on for a certain amount of time. It hits that window, then this thing goes, okay, I truly am in trouble. And then it would send to, and then all it does is close a set of contacts. And all we're doing is hitting a monitor module, which is going back to the panel and say, look, this NAC's in trouble.
Not happy.
The NAC is still operating normally, but instead of, because you had trouble contacts, you could monitor those. And put it in, set my time wrong, came back a couple days later because it tripped, and then extended that window, and that was it. And this thing's still working. So it's like, one floor, one NAC, one issue, doesn't matter what you change out. There's something going on, but who the hell knows? And at that point, you're like, okay, I can't throw any more labor at this.
Yeah.
The client doesn't want to throw any more labor at this.
And you never know. No. So that brings it. So we'll finish off the NACs at the parking structure.
Yeah.
The guy I was working with said, I can't believe this many are bad. I said, no, we got to shoot it to the end. We ended up changing 5 NACs, and then the entire circuit worked. But it's just staying with it. And he didn't want to. He couldn't believe it. I said, well, believe it. And when I showed him the blocking diodes, we kept opening the next one, bad, next one, bad, next one,
it must
bad.
have had a pulse of some sort. It must have got
something happened.
Something happened.
So, troubleshooting experience back at that ADT company. Imagine a building as big as this room we're in, literally.
That was the whole building.
That's the whole building. Had what was called a Focus 6. It was made by Aerotech, had 4 zones and 1 zone of fire. Zone 2 was your interior circuit that you always put your motion detectors on. Just how it was. You couldn't change it, how it came. And of course, when I was doing Berg and you have a false alarm, it's always the motion detector. And of course, it was zoned and it was the motion detector. Well, they just come out with dual technology detectors. So I went out to this client, I don't know, a dozen times. And it just kept tripping. It kept tripping. It kept tripping. And it was so small, I tried the dual technologies. I tried everything. I think I even strapped it out. And it didn't trip that time, but he didn't want to wait a week and not have an inter.
Oh, yeah, especially in this town.
So, well, this was, back before 93.
Oh,
I left them in 93. So anyway, again, back to troubleshooting. I had literally replaced everything but the wire. And it was still doing the problem.
Still doing it.
Brand new panel, brand new devices, brand new everything. Batteries, you name it. But even the old guy with only 16 years.
what was it?
It's a transformer.
Oh, you got to be kidding me.
And here's the deal. It was a 30 VA 16.5 volt transformer. Those ugly ass metal things with the stupid 632 nuts on them that would short out when you're there. Well, some manager at that particular branch, ADT, got like 2 boxes of those for free. Okay?
No.
Yeah. So, to save $1.
They did not save $1 with using those.
Yeah, they did. So they saved $1. And I'd changed the batteries, and I missed the obvious. What is a gel cell supposed to be normally when you have a charge on it? It's supposed to be roughly 13.8 to 1410, somewhere in there. I missed it. It was 14.6. Okay, maybe they're old, but I put new ones in, and they were charged, and I walked away. When I finally chased, and I'd replaced everything in the system but that transformer, that can't be that.
I would have never thought
Can't
that.
be that.
Never would have thought the transformer.
I didn't either. So I finally
Makes
went
me
back
wonder
to-
if this power supply is bad on that electronics.
So I went back to the panel, and the panel calls for a 16.540 VA. So I went to get one, and we couldn't get one. And it wasn't COVID stuff. It's just sometimes you couldn't get parts back then. It can't be that. And I had to order one. Had to order the proper transformer. And, of course, there's a great big beige box, and these things were stupid tiny, they were like doorbell transformers,
Yeah,
literally.
little tiny ones with the low VA on them. Yeah,
So what do you think happened when I replaced the transformer?
works good.
I put my meter on the battery, and it started going up past 13.7.
Oh, no kidding.
So it had a self-test in the middle of the nights.
Okay.
It would go on battery just to make sure every night.
And
that
then
was
the
happening.
battery would go low.
And then it was just enough of a glitch on zone 2, which zone 2, then when I called tech support for ADT, zone 2 has a tighter window of current and voltage than the other 3 zones. Like, oh my God, on a motion detection zone,
No
you
kidding.
have the lesser, you don't have the extra breadth in the.
Would they make it that way so it was more sensitive?
I don't know. It just, it was Airtech was a lead
I
company.
didn't know that. I've worked on. I've not worked on, but I've seen those focus panels. So I know
Focus
what the
6.
thing looks like. But
it was called
they
a
always
safe
had a
watch.
special key.
Yeah,
to
and it
never
was a
open
safe
up.
watch if it was a home one, but it was just the home one was white and the Focus 6 was brown. It was a good panel.
Yeah.
And all it was that
I never would have thought of that.
I didn't
never even
either.
would have looked at that. I wouldn't have looked at the transformer if you gave me $1 million.
Here I thought I was such hot stuff with 16 years experience, and I was I was called a SST, System Service Tech. I was like the elite tech at ADT before I left, and I had got a lot of special stuff. It was good. It was a good gig. But that obvious, Mike, that obvious. Nobody's immune.
Yeah.
And that's the lesson I took away is because here, you see how big this room is. That's literally how big this customer's thing. I mean, 45-second delay, they'd have the place cleaned out before that panel ever did anything. But, it was 15 VA worth of value.
Small, little, tiny things.
But had it been a big system, I'd never, ever find out. So then we had, and what that did, since I was leading the repair department, every time we had a false alarm on a Focus 6 here in Portland, told the tech, go check that transformer. And guess what? That's what it was almost every time. We'd change the transformer, zone 2 false alarms quit magically.
I'll be damned.
Over a 16.5 40 VA transformer versus a 16.5 30. 10 VA.
But that's all the difference. That makes all the difference in the world. Yeah.
And
see, in the fire, it would be all listed, so you'd have to have that. But in
this
Berg,
was a fire.
It was a commercial
combo.
Berg, so it did.
Yeah, it was commercial
listed
fire
for that. So
it was listed for commercial fire.
So this guy didn't even realize it, but he was breaking
didn't
the
care
listing
or whatever. That whole thing of, penny wise and dollar foolish.
Yeah.
So the takeaway, Mike, is that, remember I talked about checking the obvious? And I was guilty myself. Guilty myself. Yeah. But these are the lessons I take for granted. And sometimes when I look at the kids, I forget to share them.
Yeah. No, that's a really good point.
And so, teaching like you do at the same place you do now is helping me.
It does. That, that's, I didn't think about that.
There you go.
All right, my brother. Well, thank you.
Well, thank you for having me.
Oh, this is
been enjoyable.
All right.
Thanks for listening to the Halfwatt Podcast. We always want to hear from you, and we encourage you to email us at halfwattpod@gmail.com with questions or even your own stories. Funny, crazy, or praiseworthy, we want to hear it all. You can follow us on Instagram at halfwattpod to stay up to date on our feed. Be sure to subscribe wherever you listen to podcasts. And share us with a friend, the best way to help us grow. The Halfwatt Podcast is a production of Now Hear This Studios.